Hello, Algebra 2 students. Today we'll be doing 7.5 notes, apply properties of the logarithms. In 7.4, we learned how to evaluate logs and graph logarithmic functions. In this section, we're going to learn 4 important properties of logs, and those properties are listed in the table below. And you will see that there's a special note. The letters B, M, and N are going to be positive numbers, and B cannot equal 1 for these properties to hold true. That's pretty easy to remember. So the first property is called the product property. So notice on the left side, you have log base B of M times N. And if I ask you to expand it, the right side of the equal sign gives you the expanded form. So if you see two numbers multiplied together on the left side, as you do here, if I ask you to expand it, you're going to use what is known as the product property, which most people, when you think of product, you think of multiplying. So why do we see an addition? Because vice versa, if I give you the expanded form, you can condense it. That's why it's called the product property. And if you notice, the base is B. So each of these logs will still have a base of B. And the only thing different will be they'll be separated into log base B of M and log base B of N. And that's the product property. The quotient property will then, okay, if the product property involves addition, then you would think the quotient property will involve subtraction. But doesn't this make sense? Because remember the properties of exponents, when we divided with the same bases, we subtracted exponents. And that's what we're doing here. If you have a log with the same base, then you can just write the numerator and denominator separated, subtracting the bottom from the top. So again, base is B, and then these are separated. So M is right here first, and then N is listed second. And the key thing is subtraction. The power property is one of my favorites because when you see a log with a base B, then you have some number raised to the nth power. All you do is you bring that number to the very front. And that's known as the power property, n log base Bm of m. And then the last one, the change of base, makes things so much easier. So our calculator, our phone only does log base 10 because that's what our number system is in. But this change of base property lets you take the log of any base. So, and I won't get into it until we actually do some problems in our example 4. And don't even look at the change of base property formula for now. I will mention it when we go do the examples. So let's start with example number 1. Use log base 6. So use these two pieces of information. So use this and use that to evaluate those logs. Okay, so we are going to use the first 3 properties, either product property, quotient, power, or several. So the first thing you notice, you see a fraction, you instantly think quotient property. So that's what I did. So when I saw the 5/8, I'm like, okay, quotient property. So what we're going to do is we're going to expand it, rewrite it as log base 6 of 5 minus log base 6 of 8. Because that's what we can do that. We can write it in expanded form. And now log base 6/5 is the red stuff that I circled up above. So you're going to replace that with 0.898 minus log base 6/8 was given to us as it's approximately 1.161. And then you're just going to subtract those. I just used a calculator and I got negative 0.263. Okay, next one, log base 6 of 40. This one's a little harder. You have one single number like 40, and you instantly need to think, oh, what two numbers multiply together give me 40, but contain the red and green stuff that I circled above? And hopefully you see it's 5 times 8. So you can rewrite this as log base 6 of 5 times 8. Like that. And then you can use the product property. So separate them. Log base 6 of 5 plus log base 6 of 8. And then replace the log base 6 of 5 with 0.898. and the other one with 1.161. And I added those two together, and I got 2.059. And our last one, log base 6, 125. So you can't really multiply numbers together using 8 and 5 to get 125, but you could 5. You just got to have number sense. So log base 6, and I'm going to write 125. You can write it as 5 times 5 times 5, or you can write it as 5 to the third. And then that'll allow you to use the power property. Just bring this exponent right here to the very front. So 3 log base 6 of 5. And then keep your 3. Log base 6 of 5 is the red stuff I circled, and that is 0.898. And then you multiply 3 times 0.898, you get 2.102. Now, what if you didn't want to write it like that? What if you did want to write log base 6, 5 times 5 times 5? Well, then you're going to use the product property, and you're going to write log base 6, 5 plus log base 6, 5 plus log base 6, 5, and you're still going to get the same answer. So it's really totally up to you on what you decide to do. Okay, for the expansion. Okay, expanding logs is one of my favorite things to do. So again, you're going to use your properties. I looked at the problem A and immediately saw, I'm going to use the quotient property. So to expand it, you're going to write it out, log base 6, 3 minus log base 6, 7, and you're done. Okay, next one. This is a product. You're multiplying these two things together. So the first one you want to use is the product property, log base 2 of 4 plus log base 2 of x squared. You have to expand it completely. Log base 2 of 4 plus, bring this out to the front, 2 log base 2 of x. Okay, this one you can simplify if you just, honestly, you can leave it like that, but 2 to the second power gives you 4. Because remember, base is 2. 2 to what power gives you 4? And the answer is 2. So you could leave it, honestly, you could have left it like this, but this is the better answer down here. Okay, and our next one, log base 6. Oops, the base is 10 actually, but it's not see, there's no base, so that's base 10. So these two are multiplied together in the numerator, so you can separate it as log 6 plus log x squared. And this tells you that you're going to have a minus sign. So minus log y to the 4th. And then anywhere you see a power, you want to bring it out front. So you leave log 6 alone, bring this exponent to the front, and do the same thing for the last one. Okay, I'm going to skip D. Okay, for the next examples, we're going to condense. So condensing log means you're going from expanded form all the way to one single logarithm. So you see a minus sign, you're going to use the quotient property. So natural log, remember, 12 divided by 4. So that's ln 3. Okay, next one, I see all plus signs, so we're going to use the product property. So the first thing we want to do, work backwards. If this was brought out to the front, it can go right above the 2. Same with this one. And same with that one. So we have log base 4, 2 to the 5th, plus log base 4, x to the 7th, plus log base 4, y to the 4th. Okay, next thing you know is because you see the plus sign, you're going to use the product property. So just condense it all using one single log base 4. You have 2 to the 5th, x to the 7th, y to the 4th. Now, can you write that as log base 4, 32 x to the 7th, y to the 4th? Absolutely, but I'm not going to. Okay, and then our I am going to skip this one. Let's do the change of base formula to evaluate the logarithm. So this is my favorite thing in the world. That goes to the last property, change of base. So remember, you can use your calculator, your phone calculator, to do a common log with base 10, but you can't with any of these. You cannot do log, you just can't do it. So in order to get this to work, this is all you do. You take, the change of base says you take log base, or log of 8 divided by log 5. Always that bigger number divided by the smaller number. And so you punch in log 8 in your phone calculator and you get some decimal divided by log 5 that you get, and you're going to get an answer of 1.2920. And just to do that one, I'm going to just go ahead and do that one. So I'm actually going to get my phone out and I'm going to do log 8. So I'll punch in 8 and then hit LOG, not LN. So LOG, and you get, so this number gave me 0.9031. Bottom number gave me 5. So the log 5 is 0.699. I'm rounding. And then I just divided 0.9031 divided by 0.699, and I got 1.2920. So that's how I did it. I just, skip steps. So the next one is log 14. I keep wanting to say base divided by log 8. Again, use your calculator to figure that out, and that'll give you 1.2691. So use the calculator, or use the calculator to help. Okay. Next one. So I'm going to disregard the 5. Actually, no, this one's common log. So this you can just punch in your calculator. This is base 10. So you could do log 30, do 30 first in your calculator, punch in 30, then punch in log 10. Well, if you're using your phone, and then times it by 5. And I got 7.3856. And this one you can use your calculator for also. Punch in 9 first. And then I always have to check on my phone what the button says. It just says LN. So 9, then LN. So I'm going to do that. So 9, then natural log, and then times 2. So don't forget the times 2. And I got 4.3944. And those are your notes for 7.5. Have a great day, Algebra 2 students.